Welcome to our next installment of TechTalks. I'm Spencer, and I'm an MBA student here at Keenan Flagler. Today I'll be talking with Stephen King, our Chief Innovation Officer here at UNC Blue Sky Innovation Center. Today we'll be talking about quantum computing. Thanks for coming here.
Glad to be here. It's a fun topic.
Can you explain quantum computing in layman's terms for us?
Well, first of all, I should say I am a layman. I'm not a physicist, and I'm not working every day in quantum computing. But I think as we look to the future and things, we have to look and understand about quantum computing. So I'll try to explain it a little in kind of an easy way that executives and business leaders need to understand. Quantum computing is essentially a multiplier of our current existing processing power. The ability to run code and algorithms very quickly because of the underlying essence of what quantum computing is, gives us the ability to calculate things very quickly. And when I say quickly, I'm saying processing that we've never seen. It is 10-fold, 100-fold over what we are currently able to do. The way this works is essentially it uses quantum physics concepts where, if you think about current computing, we have bits, so we call them qubits that are in the quantum realm. And so essentially, instead of it just being ones and zeros, they can actually be both states at the same time because of the way quantum theory works. And so essentially, you can do lots of parallelism. Essentially, you can run lots of processes all at the same time and generate responses very quickly.
That sounds very complicated. What are some of the challenges that researchers are facing in developing this technology?
Well, first of all, there's a physics problem, right? There's a big piece. Essentially, these qubits have a tendency to die off very quickly, and I'm talking in milliseconds. So the longer you can keep these qubits alive, not alive like they're not organic, but keep qubits alive and generating for your responses, then the more you can process. So essentially what we need to do is keep it at a very cold state. So the colder you can get it, so some of the coldest places in our universe are in the center of a quantum computer. And so we have a hardware issue, and then we have a software issue of being able to read those. And so there's a lot of experimental ways of getting data out of that and understanding that. And so essentially, you've got to have these two come together and to solve these problems and make it a usable product.
Could you give me a few examples of how this technology is used in the industry?
Right now, there's very few products out there that actually leverage true quantum computing. But there is a company called Quantumum, and they absolutely are using true quantum computers. I had the great chance to talk to Tony Utley, their COO, about how they do it, and it's built on Honeywell's underlying technology. Because if you think about what is Honeywell great at doing, at keeping things really cold, and like managing flow and these types of things. And so they have that as their hardware, and then now they've added Cambridge to put on the software part of this to really make this work. And so they have offered real products that they are selling to companies. Now those companies are kind of your large big investment banks and the US government, but they're seeing value in that. And so those products right now are really around security. And so if you want to go and talk about what is the biggest fear we have with quantum computing, is that quantum computing would be able to almost instantly break our current encryption. And if you could break current encryption, that puts a lot of risk across banks, governments, all these things that we try to protect with current encryption techniques. So what has Quantumum done? They're really smart. They built a quantum protector. So essentially, it's a way to protect against some of the things that other companies, or not companies, but other bad actors might be able to do if they did have access to a quantum computer.
Thanks for talking about quantum computing. Make sure you follow our social medias and look forward to our next Tech Talk coming soon.